continue with the third segment. These are some of the applications of Geiger-Müller counter. Yeah, it could be used for detection and measurement of those activities that are listed here. Yeah, please read. There are things that Geiger-Müller counter are not used for their detection. One GM counter is not used for neutron radiation, microwave, and also radon gas emission. Now we come to the final portion or final segment, which is scintillation detectors. Yeah. Scintillation detectors are used for detecting and measuring gamma photons. It is the best detector for iodine-125 contamination to survey for iodine-125 contamination. It is several times much more efficient than compared to that when you use GM counters. An advantage of scintillation detectors, they are not going to get saturated like what you may have remembered from the previous lecture on GM counters. GM counters, when you use it for detection of high intensity radiation, it leads to the saturation of the chamber, and the output of the display would give you as though there are no radioactivity in the vicinity. So if you use scintillation detectors, the issue of saturation will not rise. The meter will pack, let me say, it will stay on the high end of the scale in an extreme radiation field. Right? So scintillation detectors, they use scintillators, which we'll see in the next slide. Scintillation detectors have a component within it, which is the scintillator. Scintillators are materials that can release light very easily, and the light or light photons, which is within the UV or visible light range. The most commonly used scintillators include inorganic scintillator. And for example, when using gamma spectrometry for radionuclides such as technetium-99m, the inorganic scintillator that are being used is sodium iodide activated with thallium, and which is written as sodium iodide, NaI bracket TL thallium. Okay, thallium activated sodium iodide are used for gamma spectrometry for low energy gammas. For example, TC99M, you know, it emits 140 keV photons. However, when you are measuring or detecting high energy photons, such as those that result from annihilation process, especially when dealing with positron emitters, and it results in annihilation by producing photons of 511 keV. Yeah? These high energy photons require inorganic scintillator, different inorganic scintillator. Usually bismuth germanate would be used for such purposes. Apart from inorganic scintillator, there are also scintillators that are in the form of organic base liquids, and these are used for beta spectroscopy, or known as liquid scintillation, for measurement of beta emission. And another type of scintillator are made of plastic material. One of the main component of scintillation detector is the unit known as photomultiplier tube, or short form as PMT. Yeah? The segment or the portion of PMT which is colored bluish is the one that we have just mentioned, the scintillators. And if this scintillation device is used for technetium-99m measurement, then the scintillator material is commonly using sodium iodide activated by thallium. But for higher photons, like in positron emission tomography, then the PM tube will be using a different scintillator crystal material. Scintillation photons are detected by the photomultiplier tube and are converted into electrons. Yeah, the scintillation photons will be converted into electrons by the photosensitive surface known as photocathode. High energy photons from radiation coming to interact with the scintillator. It emits photons or light flashes, and when it contacts the photosensitive surface photocathode, it releases low energy electrons which are converging onto the devices in the photomultiplier tubes known as diodes, and it amplifies the number of electrons. There may be 9 to 12 diodes placed within the photomultiplier tube, which are capable of amplifying from a few electrons until amplification of more than 1,000,000 times, so that this will result in amplification of signals that comes from the detector that we have mentioned. This is another schematic of the photomultiplier tube. Radiation interacts with the scintillator, produces the light like photons, and it comes into contact with photocathode. It releases electrons, which converges on the first diode, the greenish colored component, and that is being amplified on the second diode and further amplified on the third, and so forth, until at the very end towards the right, the amplification is has reached a level that it can be producing into signals as displayed towards the end. So finally, one more last homework for you. Please read through your textbook and try to come up with one nuclear medicine equipment that uses scintillation photomultiplier tubes, and for that particular equipment that you have discovered, try to get its main components and what is it used for. With that, thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh.